In this video, we're going to look at Bernoulli experiments, or binomial probability. I want you to consider this interesting question. Imagine you're in a science class and the teacher announces a 10-question pop quiz. You didn't study. Each question is 4 choices, and since you have no idea about any of the choices, you decide to randomly guess. What's the probability that you pass the quiz? So this question is something that could come up in your life, or at least it's an interesting one to think about. And the calculation for it is a little complicated. It wouldn't be something you would probably stumble upon without a little background. So that's what we're going to try to develop today, is a little background to be able to answer this question. Let's begin by considering a simple question. If you have a fair coin tossed 4 times, what's the probability of obtaining exactly 3 heads? We're going to work on this question as opposed to the one about the science quiz, because this allows us to develop some formulas, some intuition that will allow us to then go back and answer that science question. Well, it turns out the Swiss mathematician Jacob Bernoulli, back in the 1600s into the early 1700s, he was really interested in such questions about game theory and things like that. And so he developed the theory that we're going to look at today. All right, so let's consider this. Toss a fair coin meaning it's 50-50, heads or tails, 4 times. What's the probability of getting 3 heads? So maybe you have an idea already in your head what it would be. These are the possible outcomes for the 4 coin tosses. Okay, all the ways you can get 4 coins, tail or head. So what I'd like you to do is on your companion sheet, I'd like you to fill in all the numerators. Just counting them up. How many ways are there to get 0 heads? Put the numerator in, 1 head, etc. Play the recording when you've got that done. Okay, so hopefully you filled in the following numbers. And the one we're particularly interested in is what it said, 3 heads. So the ones that was 3 heads happen 4 times. Now what we're going to try to do is determine the probability without using all this sample space. This is a sample space. Okay, so clearly the answer is 4/16 or 1/4. But this is a lot of work to write out this whole sample space and count it. I certainly don't want to do that for the 10-question quiz with 4 choices each and figure all that out. Way too complicated. So let's consider this. These are the 4 flips of a coin, or tosses. Each of the halves represents the probability. Well, this one represents the probability of getting a tail, because in each case I wanted 1 tail and 3 heads. 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 The black ones are the heads, reds are the tail. Now, the question is, there are 4 different ways of this happening. The tail could have been first, second, third, or fourth. Okay? So each of those is a distinct possibility that could have come up. If I multiply all those probabilities, half by half by half by half, I get a 16th. If I add up all those 4/16ths, I get the 4/16ths, which is what we saw when we counted up the sample space. Okay, so how are we going to get this answer in a simpler way? Right now it's pretty complicated, although we can kind of see how this evolved. There's 4 different possibilities, and each of those, the t here, has a probability of occurring, which is half. And I know it's a little confusing. We're trying to use a simple example, but at the same time it's confusing because the probability of getting a head and a tail is the same. We'll get clarification as we go on. Just be patient with me and be patient with yourself here. Alright, so let's try to put this together in terms of a formula. We're trying to figure out the number of ways you can get 3 heads out of 4 tosses. So basically, how many ways can you arrange the letters T, H, H, and H? Well, think about it. There's 4 letters, so it would be 4 times 3 times 2 times 1. But I have to divide by 3 factorial because there's the 3 repeated H's. Okay? And really what that's equal to, if you think about it, that's equal to a 4. And another way to say that is 4C3. 4 items, choosing 3 at a time. So, I want you to write on your paper 4C3, 4, choose 3, and 4 represents the number of trials. There were 4 flips. 3 represents the number of successes I want, number of heads. Alright, and now we're going to multiply by the probability of each outcome. Of course, here the probability of not getting a head, a tail, is the same as probability of getting a head. And you'll notice, though, it's not the same number of tails as heads we want. We need exponents. So, we notice over here, the red ones, there were 1 tail each time. There was 1 tail each time. And there were 3 heads each time. So it was half times half times half times half. Those are those 3. And this one was the half. So if I multiply it all together, I have this number works out to be a 4, which means there are 4 of them. These numbers work out to be 1/16. And if you multiply 4 by 1/16, you get a quarter. It's the same thing we got in the first place. So what we're going to try to use is just this formula each time. Okay. Let's look at this example. What if you're on a ski vacation, you heard there was a 25% chance of snow for the next 3 days? What's the probability of it snowing 2 out of those 3 days? What I'd like you to do on your paper is write out the facts that we know. Okay? How many trials there were. In this case, a trial is a day that you happen to be on vacation. How many successes were there? In this case, we're on ski vacation. We want snow. So it's a successful day if it snowed. So how many snow days were there? Next, I need 2 probabilities. The probability of it snowing, which is provided, and the probability of it not snowing, which you have to infer is 100% minus the probability of it snowing. So fill in those 4 numbers, then we'll be able to put it together. Play the recording when you've got that done. Okay. So hopefully you filled that in. 3 trials, 3 days. 2 snow days. Probability of it snowing as a decimal, it's 0.25, and then 100 minus 0.25 leaves 75% chance of it not snowing. Now we're ready to put it together into our formula. Okay? So, we're going to start with our number of ways to have it snow on exactly 2 out of 3 days. Okay? So that's what we said here. So that would be a 3C2. I really strongly encourage you to label stuff at first, so you get it right. This is the number of days. That's the number of snow days. If you had mixed those up, guys, if you had put 2C3, it just wouldn't work. That's like saying how many ways to choose 3 items from 2. 0. And so it just wouldn't work. It would come out 0 on your calculator. Next, I have to multiply by the probability of it not snowing and the probability of it snowing. If you're worried about the order here, just remember, in multiplication, the order doesn't matter, right? What does matter is getting the exponents right. So if you put your labels in here, not snowing and snowing, and then think about how many of each of those you want, you'll nail it. Okay? So how many days do I want it not to snow? That would be over here. How many days do I want it to snow? Okay? So not snowing 1 day, snowing it 2 days. You can put that right into your calculator and evaluate it. Okay? So let's model for you how to put that. So in your calculator, you're going to first put the number of days, which is 3. Math, move over to probability, choose choice 3. So I want a 3C2. Multiply it by the 0.75, which is the probability of it not snowing. Raise that to the first power. It doesn't matter if you raise it to the first power or not, but I'm going to do it. Multiply it by 0.25, raised to the second power. These exponents have to add up to the total number of trials, the total number of days. It's either going to snow or it's not going to snow. And that works out to be 0.140625. If I want to see it as a fraction, I can. It's 9/64. Sometimes it won't let you turn it into a calculator if it's beyond its capability. Great. So there's our answer, 9/64. Just have to check how it asked you to round it.